for all you non-Harry Potter fans out there. So today's talk is titled "Every Day is a Zero Day." We're going to be talking about your internal secure SDLC, and just want to say feel free to spit out any questions, raise your hand or whatever if you have anything you want to bring up while we're going here. I'll be all ears. So a little bit about me. Just a quick overview. I got into security about a little over 2 years ago. I've really been, pure security. I've been drinking from a fire hose ever since. Before that, I did software development for 12 years. I remember towards the end of my time as software development, we started learning about what the security stuff was. I put in this, talk about implementing new functionality like RBAC. That was kind of foreign to us at the time, and this was only a couple of years ago. So the role-based access control, right? So you can see, I think, having been on both sides of this fence or this discussion, I have a good perspective on really what you're dealing with when you're working with development teams for trying to get remediation successfully. So today, like I said, every day is a zero day, and when you're working with your internal, software development teams, that's kind of what it is, right? You're always scanning, you're always testing the software to make sure before it gets out the door, you find all the bugs. So you're dealing with, a zero day, right? That's just a vulnerability that's, hasn't been disclosed to the vendor yet, right? So now you're on the internal side of this. So we're going to talk about things like, kind of how the development process works, how would you increase some security in there, how would you add value to it, right? We're going to do a value proposition here. Working with the remediation team, right? We talked about that. I think Matt, during his keynote, talked about this a little bit, right? When you disclose this stuff, it can go a couple of different ways, So think about it internally when you disclose vulnerabilities. Are you met with hostility with your development team, or do they kind of accept these things pretty well? A couple, ideas on how to measure success here, some metrics, and if we have time, we'll keep it open for discussion there. Just to show of hands, does anybody have what they would consider as like an in-house secure SDLC program? Do you have security in your SDLC right now? Okay. Do you guys do a lot of software development? Do you have a big development house? Okay. All right. All right, a couple of building blocks on what, ideas, a couple of different areas you can focus on to try to improve the security here. The first one is really understand your entire process and try to determine where you can add, some aspects of security to those steps along the way. From an SDLC process perspective. I talked about integrating your remediation into those processes, and more importantly, the prevention, right? Let's make sure that the bugs don't get into the programs in the first place, or the vulnerabilities. There's a couple tools out there, or areas where you can add tools to these processes to help a lot. And then how do you add, either accountability or more transparency about security risks? So, think about when you do find vulnerabilities, who owns them? Where do you kind of store them? Do you just take like your scan reports and put them into a password protected zip file or a spreadsheet? Or do you give them to the development team for them to kind of triage and plan out and figure out how to remediate those things? And finally, I think, always awareness is great. So how do you increase awareness with your development teams? And then also vice versa, how do you increase awareness to your security team on how your development process works? So all the development processes in every organization are going to be a little bit different. So we're going to keep this a little high level, but I think hopefully you can be able to distill that down to how it would work with your organizations. So, here's the why of why we want to do this. It costs money to fix issues, defects in general. Vulnerabilities, they can be seen as just another defect in the software program. So you want to, prevent them or find them and fix them as early as possible, right? So if you look at this chart here, it kind of shows you, if you wait until the end after the, product goes, your application goes to market, and then you find problems, it's going to be very costly to fix them. So let's kind of push security kind of up that to the left there, so we can prevent and fix the bugs, before they become too expensive here. From a software development perspective, defects just are a quality issue. So, let's try to keep those to a minimum to increase the quality overall, right? Security quality, is just one little aspect of the quality of the application. So I'm going to take a quick overview of some high-level SDLC stuff here, and I just have to stop on this chart for a second because I was originally going to put the more classic view of this thing of how a tree swing is made, and when I was trying to find the graphic, I found this one, and I think that this is pretty representative of security testing. You look at this, and from a developer perspective, you take one look at this and go, why would you set the thing on fire? And as a good, red teamer, of course you're going to try to set it on fire. You tried everything else too, right? Alternative analysis here. So, I think that happens a lot when sometimes you give some of these findings to the development team, and they say, why would you ever do that with this program? You get results like this. So real quick, development, you kind of break it down. I have a couple green boxes on here. At a high level, this is what you do, right? You have an idea of how an application should work. Let's jot some ideas down. Let's say what it should do. Put some requirements together. It shall do this. It shall do that, right? Give it to somebody else and say, hey, I've got this good description of an application I want to do. Can you figure out how to make it? So you give it to somebody to make a design and say, okay, well, we'll have it do this and this and this. Then we give it to the software guys and they're going to build it and implement it. Find out what type of tools you need, what libraries and everything. Then you're going to test and verify and make sure it works before you release it. And then it gets into a maintenance cycle. So, those green boxes kind of show the more classical picture. This is what we call waterfall, right? You'd finish one step, you go to the next one, kind of like water falling down these steps here. And that has evolved over time. So those green boxes, if you were to just loop back around to the top of them and consider that like one iteration of development, some of the new methodologies out there like Spiral, that's just multiple iterations of development. You'll see, the idea of prototypes coming in, trying to get to more of a, working product early on so you can make some determinations of if your design is good. Do you need to course correct it all, before you get to the very end and have to fix everything. Nowadays, agile development with your DevOps programs is, much more popular too. And really all that is just all those different circles are just more iterations, right? We get them down to smaller, chunks of functionality to get a product or functionality out the door a little bit quicker. You can also, fix it or adjust it a little bit quicker, And part of this is brought on just by increases in technology in these areas, continuous integration, continuous test, continuous deployment. And we'll talk about that a little bit later on. Finally, for developers, you get a lot of testing on their applications, right? I have put a couple on here. I'm sure there's more. I think we all know different ones on here. The ones on the bottom are a little bit more newer than some of the other ones. So, security is certainly very important for nowadays from an application, depending on how that application is used. But, when you find issues with testing, you're competing with all these other, testing efforts as well. So how do you prioritize those things? How do you make your case for that the security bugs are more important than some of the other bugs there? Are you coming up against a brick wall? Do you have an open rapport with the development team to try to make that happen? The other thing too is like, when are you doing this testing, right? We talk about different stages of development, and, the different testing that can happen at those stages. And there's, different types of testing you do. When, you might just want to scope it down to new functionality because it's new, you want to make sure it works. But you also want to make sure you didn't break anything in the process, so you want to regression test everything. It goes the same for security, but, it's kind of impractical to do full regression testing every time you have to put a new release out or a new build. So you're kind of, taking a risk-based approach to testing here. And, the same thing goes for the security. And, really, I just want to jump back to, these determinations of the accountability, right? Who makes a determination for how much testing should be done on the application, especially from a security perspective? Is that going to be done by your development team or is it done by your security team? Who should own that? Then we have acceptance testing. I think, a lot of people can figure this out, right? We're going to deliver this product. We want to make sure we get a clean security scan on it before it goes out there, make sure there's nothing on that. Maybe that's just an automated scan. Maybe you're going to do a pen test as well. And then finally, we always talk about with testing, free play. You find stuff sometimes when you're not expecting to. So you don't have really, you're following a test script or anything. You just, something falls out of the program. Or you're testing it on an ad hoc basis. Vulnerability scanning, if it's something that you maybe are doing monthly or quarterly, or whatever, that's going to fall into that last category there because, it's not integrated into the development cycle. So when you find something, when you're in that, doing those scans regularly, we don't exactly have a build ready to go ahead and fix it with. You might not have resources available. So, okay, so how do we add value to your software development lifecycle, right? We need to kind of justify why we want to add this cost to your stakeholders so that when they ask you, what am I paying for, you can kind of answer that question. So what I have up here is this is actually a diagram. I don't know if anybody recognizes this. This is actually Microsoft's secure development lifecycle diagram. It comes right out of their documents. Back when Microsoft had an SDL. Still very valuable, documentation there. But you'll see the green boxes. I made mine green for the same reason. But the same 5 boxes for the most part are in here too. So what this shows you is what you can do at each phase along the way from a security perspective to really kind of add security, right? Try to identify defects, prevent them. How do you document different things? Reviews. Different quality gates that you can go through to make sure that, when you're doing maybe your design or your architecture, you have a process that says, okay, when we're doing that, we're going to have a security aspect to it. And it also has training, obviously, from an awareness perspective and an incident response. But a couple things on here that it's missing that I like to add to. I mentioned architecture review. I think having a, architecture review is very important. It's something pretty basic you can do for applications. Every time they're going to plan a release, make sure they notify your security team so you can take a look at it. So when, they're trying to deploy a program with, out-of-date libraries, you can kind of take one look and say, hey, maybe you guys should update these. The other thing too is, in the implementation phase, you make sure they're using safe libraries. We'll get into, libraries a little bit later here, but those are a couple steps too, along with all these other ones over here, right? So adding some of these, right, there's a cost to that. You're going to have to add people, resources, time, money to do that. So what do you get out of it, right? So there's a benefit to that too. And a lot of these are pretty obvious. You want to make sure bad guys can't get in. You want to make sure your information can't get out. Maybe you have a compliance reason for doing this sort of stuff. You want to increase awareness, right? When you tell a development team, hey, we're going to follow this new process and has security in it, well, they're going to probably be aware of a little bit of security. Maybe that'll pique some curiosity and they'll get more involved with on the security side of things. And finally, cost reduction. As I showed you before, right, the bugs are expensive, so let's find them earlier on so we can decrease costs. So why do you need, this program? Do we have bugs in our program, right? So what I did was I took a look, kind of looked at some public bug databases to try to see what was out there. You might have heard of these programs before. Firefox, if you look at it currently, 14 million lines of code. If you look at going to bugzilla.mozilla.org, you look for Firefox product and you look for the security component in there, it's got 466 open defects in there. So if you look at that currently, that gives you a defect rate of 1 per every 30,000 lines of code. So 30,000 lines of code is really not a lot of code these days, right? I mean, how many programs, mature programs, really that are, kind of out the door products have less than like 100,000 lines of code in them. Then I took, and these numbers aren't as meaningful, but I took a look at the NVD, the National Vulnerability Database, to see how many vulnerabilities there are out there against that product. And I compared that to the lines of code. So you could argue that, the current amount of lines of code doesn't have all those vulnerabilities in it. And I agree, right? Some of them have been closed, some of those are old ones. But it's just the idea of, how do we, what type of metrics are useful for our applications? So I put that one up there just kind of as a thought process. Then I took Google Chrome, did the same thing. Very similar. I was actually surprised. I had to double check the numbers here, how similar they were. Both similar lines of code, one different open defect between the two programs from a security perspective. So the defect rate is in line, 32,000 lines of code, and a similar number of CVEs. So then I took glibc, and for everybody who doesn't know what that is, that's the library you need to run C++ programs in Linux. I took a look at that library. So it's much smaller, right? 1.25 million lines of code, 914 open defects, with a security flag in there. So that gives you a defect rate, of 1 every 1,370 lines of code versus 30,000 lines of code for web browsers, but much less fewer CVEs. So I don't want to make too many, presumptions about what this tells you. You could argue maybe there's still a lot of untapped vulnerability potential in that library. Or, the other thing is the attack surface is so big, you're only going to use a small portion of it, so it might not be as much of a concern for you. But libraries like glibc, your program's going to use, it's going to inherit all the vulnerabilities that your application, that library has that your application now has as well. So, even though you might write a small program, it's in C++, you're going to run on Linux, you're going to be running glibc. It's hard to tell exactly how many lines in there you're going to run until you really do an attack surface evaluation there. But you need to keep in mind, and this is what I talk about with safe libraries, is knowing what is out there from a vulnerability perspective that you're going to inherit in, right? So these just go right on top of anything you wrote in your custom code as well. And then how do you fix these, right? How does your application fix these? When these came out, it's not like there's a patch available, right? Your development team has to actually fix that. They have to write the code. They have to recompile it. They have to rebuild it, right? And then what is that process? As you as a security provider, do you know how your company handles that process, right? Would this warrant an emergency patch? Some sort of out of schedule release for an application? Probably, but who makes that determination? Do you follow the same process you would if from a functional perspective something like this would happen? You deploy an application and it breaks. What do you do in that case? So, for those of you who don't know the getAttr info, it doesn't have a logo, but it's out of glibc, so I put it up there. Had a CVSS score of 8.1 with an exploitability of 10, so it was a big one. So how do you work with your remediation team? So, in case you're wondering who your remediation team is for this, it's going to be your developers. So do you have a rapport with them? Do you have a relationship, that goes well? You can kind of reach out and say, hey, ask them a question, right? Try to be in front of vulnerabilities. Do you guys use this library when you see reports come in? Or ask them a question about, do you have this problem? Things like that. So I have a couple tips for how to kind of work with that relationship. When we build up that relationship, I think you want to, figure out how to have that dialogue with your security teams. The first suggestion I have is just like any pen test, right? You do your recon. So you want to know what type of architectures you're running. You don't want to give them, suggestions for how to remediate something for the wrong architecture, right? Don't give them examples of WordPress vulnerabilities if you're really running, an Apache shop, or for desktop guys, if you're, if it's .NET runtime versus, like an Eclipse Java runtime, make sure you know what to do there. Understand their process so that, when you have vulnerabilities you need to disclose to that team, you have a good idea of when they're going to get fixed, right? If they don't have a build planned for maybe 6 months or a year, maybe it's something that has an annual release, and you find a critical vulnerability, what are you going to do about that? Understanding how that process is going to work on their side, how do they take defects? Do they have a change control or change review process that happens where they triage and prioritize all of their different defects to figure out what to fix? Try to get into that process. And then, these are just pretty simple recommendations here. Don't add more work. False positive reduction, I think everybody knows what to do there, because that's just going to come back. The last thing you want to do is, for anybody, when you hand somebody a report with false positives in it, it's going to be more work for both of you, and it's going to kind of, weaken that relationship. So, especially when you're doing it internally, you may think, oh, well, it's internal, I don't have to worry about putting such a good spin on this thing. I'm just going to give them the whole raw report. Well, you get to, development team, and they might say, oh, we need to fix these vulnerabilities, and they start looking at them, and they go, we can't reproduce this, right? And that's something I think that most developers don't like to see when they're given a problem report that isn't real. It's just a waste of time, And then make sure that the recommendations are relevant. I'll get some examples of this, but that kind of goes back to the architecture a little bit. Understand the context of your application, how that works, and if you don't know, then ask the development team. Say, hey, how do you guys, do authentication, right? We found this bug, but we don't know if it's legitimate or not. Do you use LDAP, right? Maybe my LDAP injection is a false positive because you guys don't even use LDAP, something like that. So here's one example. Don't get me wrong, I love burp as a tool, but sometimes the reports out of their scanner can leave a little to be desired because of confidence. So, if you were to just give somebody a, automated report and you have a bunch of tentative confidence in there, you're kind of, rolling the dice on what's going to happen out of that. So, I put this example up here, just a little backstory on it. So what happened while the scanner was running was it runs the first request, right, and it comes back and gives it a response. It runs the second request, it came back with a 408 response. So that's that the thing timed out. So in its logic, it says these are different. I'm going to flag it as potential SQL injection response. So, but burp is at least nice enough to tell you, and I put the green box around it, that these results are unreliable, so they need manual and verification. So make sure you do that. Second example is, as I talked about, make sure your recommendations are relevant. So this is right out of OWASP's website on preventing SQL injection. So just show of hands, has anybody ever tried option number 2 on here? You have? Okay. Do you know why you had to go with that? With the stored procedures or whatever? Do you use storage procedures? All right. Okay. All right. So typically, if you're already using stored procedures, that makes sense. But I haven't really come across too many instances where that's the case, and it's more work. So usually option 1 just makes sense. So make sure these recommendations are relevant before you just put them in your report. The last thing is I kind of alluded to this a little bit, but when you get all these vulnerabilities and you get a big report, what do you do with them, right? I talked about the transparency. So, one of the best things you can do is get those defects into the right systems. So whatever system that your developers use, the dev guys, whatever system that your operations guys use, your ops guys, make sure you're using the same system, right? Come up with a severity mapping between what their system does and what your tools do from a criticality perspective, and then enter these defects or these bugs into their systems. So what's going to happen there is that when an application team or development team is going to look at their application and see what kind of their defect totals look like, the security stuff's going to be in there. I know I've come across a couple instances where this doesn't happen. You kind of keep your separate set of books on vulnerabilities, and it's tough to kind of see the big picture here from a risk score perspective or enterprise attack surface, because they're not all in the same system. So get them into the same system, whatever that is, and keep the tracking in there, right? From the security teams, if you want to look at the SDLC risk, run your reports out of their systems. It makes a lot of reporting easier, and it also, like I said, the transparency's there, and it helps you build that case towards accountability, right? The dev team can't ignore these findings if they're in their defect systems, So that when there's some considerations here is that when they're trying to plan their next build or release, from a budgeting or a schedule or a resource perspective, those bugs are already in their backlog. All right. So the other thing is you can empower your developers, right? Let's give them some security tools that they can use here as well. So, typically development teams will have, an integrated development environment IDE. A couple popular ones are like Eclipse or Visual Studio. Those come with tools. Visual Studio has, a security rule sets you can turn on. And what this is going to do is kind of going to check the code in real time or at compile time to kind of flag some security issues before those can really leave the developer and get into your code base. So something you want to consider, turning those on for your developers, and then you need to support them too. So after you turn them on, you're going to have to work with your development teams to make sure that the rule set that you have is good. You want to have the right, all the different, the profile set up properly so that they don't have the false positives in there, so it can be effective for them. You also don't want to turn off too much stuff, lower the sensitivity so you're not catching everything either. And then, I talked a little bit about Agile and some DevOps stuff. Those really come around, like I said, with automation. So, there's a couple tools out there. Jenkins is a popular one. Chef's another one. There are tools. I mean, most of the scanners, vulnerability scanners, you can integrate in to your development processes, right? We have a kind of a build pipeline up here. You build something, you want to kick it off to a build. First thing it does is tests it, right? Well, run your static code analysis there. Make sure you get a clean static scan on the thing. And if you don't, maybe you want to have a rule of saying a process, all critical and high vulnerabilities need to be remediated, right? And if you find any, break the build, right? There's build breaker plugins for a lot of security tools that allow you to do that, so that the developer is going to see a failure in their build pipeline. They're going to have to fix it before they can really promote it up to another level. After you build the thing, you deploy it to a test environment, run your vulnerability scans on it, run the dynamic stuff. Catch it there. The same thing. Let's make sure we get clean scans, however you determine that to be for your organization. Okay, so you're trying to measure your success of your project a little bit here. I have a picture of Grace Hopper. She's credited with finding the first bug. I think if we follow this process for security bugs, we'd probably run out of tape pretty quick. But we have a couple other tools we can do. So one of the things I did is, I don't know how well you can see this, but I took all those bugs and plotted them for Firefox over time. So what this chart's showing is at the bottom there in the orange line at the bottom, every month that's how many bugs, defects, security defects were opened against Firefox. The green line is how many were closed. So, every time that the orange line goes above the green line, you have a residual number of bugs that are in your tool, right? That's the blue line. So over time, your security risk of your application will grow if you're not fixing everything you're finding. So if you look at something like Firefox, those numbers are 30, 40, 50. So this is kind of what I meant when I was saying like every day is a 0 day, right? The security guys are going to be dealing with an application like this, and they're going to either be fixing a bug, getting that green line up, or they're going to be dealing with a new bug from a security perspective here. This is a great chart to start charting, showing across your organization. Take your vulnerability scans and show over time how they increase. To try to get backing to say, hey, we need to do something about this. So if you look at the end of 2010 here, Mozilla, for some reason they took it at the end of January. They fixed 100 bugs in Firefox. It seems like something changed. Their processes changed. Their security team got more involved. Something happened to really, I think, kind of corral the security issues in this product, right? So what you see there is you see something similar to, more of a plateau there. And I say plateaus, it flattens out because, you got to think about it. The code base continues to increase. So the, the ratio of bugs per lines of code, it probably stayed flat, or it could potentially, decrease with this chart. So I'm going to dive into this a little bit closer here. I'm going to break those out, this open defects by severity. So if you see there, the top line there it's categorized as normal, right? So I think Firefox, as an application, decided we're going to accept the risk of normal bugs. We don't need to do anything about them. There are no cause for alarm. We're going to take some of these other higher criticality ones, the majors, the minors, and we're going to, make sure we keep our arms around those and we don't let them get out of control. So I filter out a couple of those, and we just look at the critical, major, minor, and trivials. You can see at the end of 2010, Firefox, they really, got their hands around security. They made a concerted effort to decrease, a lot of the more critical bugs in their tool, and they kept them, they kept improving them. They're doing a good job, and I don't know if that's because their developers got smarter, so they're doing more prevention. They just got more active on remediation. I doubt it's because they're doing less testing, but taking a chart like this and kind of showing that for your organization, can really tell a story here. At what point do you get your hands around the security of your applications, right? And this doesn't need to just be one application, right? Let's put all your applications on one chart and show your enterprise risk score, right? And then you can start pointing fingers, right? So you can say, we have this problem application over here. It needs to get fixed. It's really driving up our risk score, but now you have some data behind it, right? So this data is really easy to get. out of Bugzilla, you just run a CSV report so you can show it. Same thing for most of the other defect tracking tools out there. The other way to kind of measure success is to determine the maturity of your program. So a couple ways to do that. There's a lot of ways to do that. There are plenty of frameworks and everything. I just have two that I called out here. The one on the right, for anybody recognizes that's CMMI. It comes at 5 levels. Typically, I think you got to figure out where your sweet spot is. From a process perspective, where are you now? Where do you want to be? Take a look at it on there. One thing to note about CMMI is you're probably not going to be able to get attain a score higher than your development team follows, just because if you're trying to integrate into the SDLC processes, you're kind of stuck with whatever maturity that they have as well. The other one on here is OpenSAM, the Software Assurance Maturity Model. It provides 12 different categories. You give yourself a score of 0, 1, 2, or 3, and you can kind of, score your current processes. Then you can take a look and you can say, where do we want to be, right? And you can kind of, put that roadmap together of how to, increase your security. Do you need to add more processes? Do you need to add more steps along the way to the SDLC? And the things you need to look at when you're trying to determine these things, look at your artifacts. Are you even doing these artifacts? And then look at your processes. Where do you have security in your program? Do you just do offline scans at the end? Do you make sure you have some sort of pre-production deployment step, or are you really fully integrated in all the way up in the design and the the requirements phases here? Okay, so I'm just going to wrap it up here. Just a couple thoughts here. When I say every day is a 0 day, when you're working with your, Secure SDLC as working with your development teams, it really is. You want to make sure, it's no different than, any other 0 days out there. They're probably not as high profile, but, for your organization, for your brand reputation, these things can be very, very important. So with that being said, right now I'll just take any questions on anything. All right. All right, that's all. Thank you.